Today we're launching our new segment, This Week in Space, where we will give you the most exciting space updates and game-changing space discoveries. In this first episode, the Euclid Telescope's groundbreaking images revealed new details of galaxy formation and structure, offering fresh insights into star creation in the local universe. On June 5th, Boeing finally launched their first crewed mission using the Starliner Spacecraft and successfully docked with the International Space Station.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel.
NASA's Psyche, after 6 months in space, finally fired up its sci-fi-worthy thrusters. And the James Webb Space Telescope captured the sharpest infrared images of the Horsehead Nebula. Euclid's space mission released 5 unprecedented new views of the universe. The never-before-seen images demonstrated Euclid's ability to unravel the secrets of the cosmos and enable scientists to hunt for rogue planets, use gravitational lensing of galaxies to study mysterious matter, and explore the evolution of the universe. The new images were part of Euclid's early release observations. They accompany the mission's first scientific datasets made public and 10 forthcoming science papers. The treasure trove came less than a year after the Space Telescope's launch and roughly 6 months after it returned its first full-color images of the cosmos. Valeria Pettorino, ESA's Euclid project scientist, also said, "Euclid is a unique, groundbreaking mission, and these are the first datasets to be made public. It's an important milestone."
These images are visually very beautiful, but they are also very informative. They really demonstrate how Euclid can look at a very large field of view. It can really look at the sky, showing full clusters of galaxies, but also show at the same time very tiny details. And some of the images really show them that there's thousands, hundreds of thousands of objects in one image.
She added, the ESA's Euclid project scientist emphasized, the images and associated science findings are impressively diverse in terms of the objects and distances observed. They include various science applications, and yet represent a mere 24 hours of observations. They give just a hint of what Euclid can do. We are looking forward to 6 more years of data to come. The full set of early observations targeted 17 astronomical objects, from nearby clouds of gas and dust to distant clusters of galaxies, ahead of Euclid's main survey. This survey aims to uncover the secrets of the dark cosmos and reveal how and why the universe looks as it does today. Euclid is a European Space Agency, ESA, mission with contributions from NASA, involving over 2,000 scientists from 300 institutes worldwide. Thales Alenia Space built the satellite, Airbus Defence and Space developed the payload module, and NASA provided detectors for the near-infrared spectrometer and photometer. As part of ESA's Cosmic Vision program, Euclid aims to trace the universe's web-like foundations, map billions of galaxies, and study dark energy and dark matter. This space telescope intends to tackle the biggest open questions in cosmology, adds Valeria. And these early observations demonstrate that Euclid is more than up to the task. Now, let's shift our focus to those remarkable images from Euclid. Imagine this. Images that were 4 times sharper than those from ground-based telescopes explore the distant universe in visible and infrared light. The results we're seeing from Euclid are unprecedented, says ESA Director of Science, Professor Carol Mundell. So, without further ado, let's dive into these extraordinary images and unlock the mysteries they hold. Let's take a look first at Euclid's image of galaxy cluster. Able 2390 reveals more than 50,000 galaxies and shows a beautiful display of gravitational lensing, depicting giant curved arcs on the sky, some of which are multiple views of the same distant object. Euclid will use lensing, where the light traveling to us from distant galaxies is bent and distorted by gravity, as a key technique for exploring the dark universe, indirectly measuring the amount and distribution of dark matter both in galaxy clusters and elsewhere. This breathtaking image featured Messier 78, a vibrant star nursery enveloped in interstellar dust. Euclid peered deep into this nursery using its infrared camera, exposing hidden regions of star formation for the first time, mapping its complex filaments of gas and dust in unprecedented detail, and uncovering newly formed stars and planets. Euclid's instruments can detect objects just a few times the mass of Jupiter, and its infrared eyes reveal over 300,000 new objects in this field of view alone. In this image, Euclid presented NGC 6744, an example of the type of galaxy currently forming the majority of stars in the local universe. Euclid's large field of view covers the entire galaxy, capturing not only spiral structures on larger scales, but also exquisite detail on small spatial scales. This includes feather-like lanes of dust emerging as spurs from the spiral arms, shown here with incredible clarity. The view of galaxy cluster, Abell 2764, top right, comprised hundreds of galaxies within a vast halo of dark matter. Euclid captures many objects in this patch of sky, including background galaxies, more distant clusters, and interacting galaxies, throwing off streams and shells of stars. This complete view of Abell 2764 and surroundings, obtained thanks to Euclid's impressively wide field of view, allows scientists to ascertain the radius of the cluster and see its outskirts with faraway galaxies still in the frame. In this image, we also observed a bright foreground star, VBP Phoenicis HD 1973, situated within our galaxy's southern hemisphere. Its brightness was nearly visible to the naked eye. When viewed through a telescope, the star's light scatters into a diffuse circular halo due to the telescope's optics. As you can see here, Euclid captured galaxies evolving and merging in action in the Dorado Galaxy Group, with beautiful tidal tails and shells seen as a result of ongoing interactions. Scientists have used this dataset to study how galaxies evolve, to improve our models of cosmic history, and to understand how galaxies form within halos of dark matter. This image showcases Euclid's versatility. A wide array of galaxies were visible here, from very bright to very faint. Thanks to Euclid's wide field of view, depth, and high resolution, it captured star clusters, galaxy cores, and tidal tails in one frame. NASA originally targeted a June 1st launch for the first crewed flight of Boeing's Starliner spacecraft. However, the mission was plagued by delays. The delays were caused by seemingly minor issues that necessitated a Delta Agency flight test readiness review to evaluate the work performed since the last launch attempt on May 6th. Ultimately, after addressing these technical hurdles, the Starliner spacecraft finally launched successfully on June 5th. NASA's Boeing crew flight test, with astronauts Butch Wilmore and Suni Williams, lifted off at 10:52 Eastern Daylight Time, marking a historic first for Boeing's Starliner spacecraft. A United Launch Alliance Atlas V rocket carried them from Cape Canaveral Space Force Station in Florida to the International Space Station. And after nearly 27 hours, the Starliner crew successfully docked with the station's Harmony module on June 6th. The success of this crewed flight follows two previous uncrewed orbital flights for the Starliner spacecraft, including one to and from the International Space Station and a pad abort test. This mission, part of NASA's Commercial Crew Program, aimed to validate the entire Starliner system, from the launch pad and rocket to the spacecraft, in-orbit operations, and crew return capabilities. This data is crucial for certifying Starliner for regular crew missions to the ISS. NASA Administrator Bill Nelson enthusiastically declared this mission a new chapter of American exploration and emphasized the importance of human spaceflight challenges. He concluded with good wishes for Starliner, the astronauts, and the future of space exploration. If you want to know more about Boeing's Starliner, check out our video about Boeing's epic $4.3 billion Starliner failure exposed. NASA's Psyche spacecraft passed its 6-month checkup with a clean bill of health, and there's no holding back now. Navigators fired its futuristic-looking electric thrusters, which emit a blue glow, nearly non-stop as the orbiter zips farther into deep space. The spacecraft launched from NASA's Kennedy Space Center in Florida, atop a SpaceX Falcon Heavy on October 13, 2023. After leaving our atmosphere, Psyche made the most of its rocket boost and is currently coasting toward Mars to use its gravity to slingshot toward the asteroid belt. The spacecraft will be in what mission planners call full cruise mode for the next year. Its electric thrusters take over and propel the orbiter toward the asteroid belt. The thrusters work by expelling charged atoms, or ions, of xenon, emitting a brilliant blue glow that trails behind the spacecraft. They are part of Psyche's incredibly efficient solar electric propulsion system, which is powered by sunlight. The thrust created by the ionized xenon is gentle, but it does the job. Even in full cruise mode, the pressure exerted by the thrusters is about what you'd feel holding 3/4 in your hand. The Psyche orbiter is now over 190 million miles, 300 million kilometers, from Earth, traveling at 84,000 miles per hour, 135,000 kilometers per hour. With no atmospheric drag, it will eventually accelerate to 124,000 miles per hour, 200,000 kilometers per hour. The spacecraft will reach the metal-rich asteroid Psyche in 2029 and spend 2 years making observations. This data will help scientists understand the formation of rocky planets with metallic cores, like Earth. It's estimated to be roughly 173 miles, 280 kilometers wide, and Psyche is thought to be mostly metal, nickel, and iron, making it a potentially exposed core of a planetesimal, a building block of early planets. In its first 100 days, the flight team conducted a full systems check, confirming all engineering systems and science instruments were functioning perfectly. The magnetometer detected charged particles from the Sun, and the gamma-ray and neutron spectrometer also performed well. The imaging instrument's cameras captured their first images. "All systems are working beautifully," said Henry Stone, Psyche project manager at NASA's Jet Propulsion Laboratory. "We are now looking forward to an upcoming close flyby of Mars." The spacecraft will approach Mars in spring 2026, using its gravity to slingshot toward the asteroid Psyche before resuming full thruster power. The Deep Space Optical Communications (DSOC) technology aboard the spacecraft is testing effectively, having transmitted data at 267 megabits per second from over 140 million miles away. Arizona State University leads the Psyche mission, with Jet Propulsion Laboratory managing the project, including system engineering and operations. Maxar Technologies provided the spacecraft chassis. JPL also manages DSOC. The Psyche mission is part of NASA's Discovery program, managed by Marshall Space Flight Center, and the launch was overseen by NASA's Launch Services program at Kennedy Space Center. NASA's James Webb Space Telescope has captured the sharpest infrared images to date of a zoomed-in portion of one of the most distinctive objects in our skies, the constellation Orion, the Hunter, in the western side of a dense region known as the Orion B molecular cloud. Rising from turbulent waves of dust and gas is the Horsehead Nebula. These observations showed the top of the horse's mane or edge of this iconic nebula in a new light, capturing the region's complexity with unprecedented spatial resolution. This image showcased 3 views of one of the most distinctive objects in our skies, the Horsehead Nebula. The first image, released in November 2023, featured the Horsehead Nebula as seen in visible light by ESA's Euclid Telescope, which has contributions from NASA. The second image showed a view of the Horsehead Nebula in near-infrared light from NASA's Hubble Space Telescope, which was featured as the telescope's 23rd anniversary image in 2013. This image revealed a beautiful, delicate structure that was normally obscured by dust. The third image featured a new view of the Horsehead Nebula from NASA's James Webb Space Telescope's NIRCam, near-infrared camera, instrument. This image of the Horsehead Nebula, captured by NASA's James Webb Space Telescope, focuses on a section of the nebula's mane, about 0.8 light-years wide. Taken with Webb's NIRCam, near-infrared camera, the blue ethereal clouds at the bottom consist of cold molecular hydrogen, while the red wisps above were primarily atomic hydrogen gas. This area, known as a photodissociation region, featured ultraviolet light from nearby young, massive stars, creating a neutral, warm zone of gas and dust between the ionized gas above and the colder nebula below. Distant galaxies were visible in the background. This image of the Horsehead Nebula from NASA's James Webb Space Telescope focused on a portion of the horse's mane. It was taken with Webb's MIRI, mid-infrared instrument. Mid-infrared light captured the glow of substances like dusty silicates and soot-like molecules called polycyclic aromatic hydrocarbons. Next, astronomers intend to study the spectroscopic data that has been obtained to gain insights into the evolution of the physical and chemical properties of the material observed across the nebula. That's all for this episode of the latest updates in space. We hope you enjoyed exploring these incredible discoveries and missions. Now we want to hear from you. What space topics are you most interested in? Do you have any burning questions about the universe? Share your thoughts in the comments below. Don't forget to like this video, share it with your friends, and subscribe to our channel for more exciting space updates. Hit the notification bell so you never miss an episode. Who knows? Maybe one day we'll be reporting on your journey to the stars. Until next time, keep looking up.